Proxima Centauri, the closest star to our solar system, has long been a subject of fascination for astronomers. This small red dwarf, discovered in 1915 by Scottish astronomer Robert Innes, is part of the Alpha Centauri system, which also includes Alpha Centauri A and B. Despite its proximity just 4.24 light-years away, it remains invisible to the naked eye due to its relatively low brightness. However, Proxima Centauri holds immense scientific value, especially as the host star of Proxima B, an exoplanet that orbits within the star's habitable zone. Red dwarfs like Proxima Centauri are smaller, cooler, and much longer-lived than stars like our Sun. Their low luminosity makes them challenging to observe, but it also means that their habitable zones are much closer to the star. For Proxima Centauri, this translates to an orbital distance of just 0.005 astronomical units, a mere fraction of the distance between Earth and the Sun. This close proximity exposes Proxima B to intense stellar activity, including frequent solar flares and high levels of radiation, making its environment starkly different from Earth's. The discovery of Proxima B was a monumental achievement in exoplanet research. Using the radial velocity method, astronomers detected subtle wobbles in Proxima Centauri's position, caused by the gravitational pull of an orbiting planet. These wobbles allowed scientists to estimate the planet's mass and orbital period. In 2016, the European Southern Observatory officially confirmed the existence of Proxima B, marking a breakthrough in the search for potentially habitable worlds beyond our solar system. While ground-based observations have provided valuable insights into Proxima B, they come with significant limitations. Atmospheric distortion and light interference hinder the ability of Earth-based telescopes to capture detailed data about the planet's surface or atmosphere. Most of the information we have, such as its mass, distance from the star, and orbital characteristics, relies on indirect measurements to uncover deeper truths about Proxima's environment and its potential for life. More advanced observational tools like the James Webb Space Telescope (JWST) are indispensable. Proxima Centauri's role as a gateway to understanding exoplanetary systems cannot be overstated. As the closest star system to Earth, it offers a unique opportunity to study the conditions necessary for life. Proxima B in particular represents a tantalizing possibility, a rocky, Earth-sized planet with the potential to harbor water and maybe even life. However, the challenges posed by its harsh environment make it a complex puzzle for scientists to solve. The James Webb Space Telescope (JWST) is not just another tool in the arsenal of astronomy, it is a revolution designed as the successor to the Hubble Space Telescope. JWST was envisioned to address the limitations of its predecessor and push the boundaries of human knowledge. While Hubble has provided invaluable insights into the cosmos, its capabilities are constrained by its focus on visible and ultraviolet light. WST, in contrast, is built to observe the universe in infrared wavelengths, allowing it to peer through cosmic dust and uncover phenomena invisible to Hubble. One of the key design features of JWST is its primary mirror, which spans a staggering 6.5 m in diameter, more than double the size of Hubble's mirror. This larger mirror enables JWST to collect far more light, making it capable of observing extremely faint and distant objects coated with a thin layer of gold. To enhance its infrared reflectivity, the mirror is composed of 18 hexagonal segments that work together to create a highly sensitive observational platform. Another groundbreaking innovation is JWST's layer of sunshield, which keeps the telescope's instruments at a constant temperature of about -233 degrees C. This ultra-cold environment is crucial for detecting faint infrared signals without interference from the telescope's own heat, unlike Hubble, which orbits Earth. JWST operates from the second Lagrange point L2, a stable position approximately 1.5 million kilometers from our planet. This location minimizes interference from Earth's heat and light, allowing JWST to maintain continuous observations. The telescope can study everything from the earliest galaxies to the atmospheres of exoplanets like Proxima B. Its focus on infrared light is particularly significant as it allows astronomers to study phenomena that are redshifted objects whose light has been stretched to longer wavelengths. As the universe expands, JWST's capabilities extend far beyond mere observation. It is designed to answer some of the most profound questions in science, including the origins of galaxies, the formation of stars, and the conditions that might support life on other planets. With its state-of-the-art instruments, including the near-infrared camera and IR cam, the infrared instrument mirror, and the near-infrared spectrograph NIR spec, JWST is not just a telescope, it is a time machine, a laboratory, and a beacon of human ingenuity. Proxima B has captivated scientists and the public alike as a potential second Earth situated within the habitable zone of its star. The planet has the right conditions to potentially support liquid water, a key ingredient for life as we know it. With it mass roughly 1.17 times that of Earth, Proxima B is likely a rocky planet, similar in composition to our own. Its proximity to Earth, just over 4 light years away, makes it an ideal target for studying the potential for life beyond our solar system. However, Proxima B is far from a perfect twin of Earth. One of its most striking features is that it is tidally locked, meaning one side of the planet is in perpetual daylight while the other is in eternal darkness. This creates a unique environment with extreme temperature differences between the two hemispheres. The region where day meets night, known as the Terminator line, may offer a narrow twilight zone with conditions moderate enough to support life. The challenges posed by Proxima B's environment are significant. Its host star, Proxima Centauri, is a red dwarf known for its intense solar flares, which can emit bursts of X-rays and ultraviolet radiation. These flares could strip away the planet's atmosphere over time, exposing its surface to the harshness of space. If Proxima B retains any atmosphere, it likely requires a strong magnetic field to shield it from radiation. Without such protection, the surface environment would be hostile to life as we know it. Despite these challenges, scientists are optimistic about the potential for life on Proxima B. The planet's position within the habitable zone suggests that liquid water could exist either on its surface or in subsurface reservoirs. Life might adapt to the harsh conditions, much like extremophiles on Earth. Organisms that thrive in extreme environments such as deep-sea hydrothermal vents or high radiation zones. These adaptations could include radiation resistance, subsurface habitats, or unique biochemical processes. The search for life on Proxima B is more than just a scientific endeavor. It is a quest to answer one of humanity's oldest questions: are we alone in the universe? Proxima represents a tantalizing possibility, a rocky Earth-like world that might harbor the conditions necessary for life. As our technology advances, so too does our ability to explore this intriguing planet and uncover its secrets. While Proxima B presents tantalizing possibilities, its environment is profoundly influenced by the nature of its host star, Proxima Centauri. Unlike our Sun, Proxima Centauri is a red dwarf star, smaller, cooler, and significantly less luminous. Its reduced size and temperature mean that its habitable zone is much closer, pulling Proxima B into an orbit just 0.05 astronomical units from the star, about 20 times closer than Earth is to the Sun. This proximity creates a unique set of challenges for the planet and any potential life it might host. One major issue is Proxima Centauri stellar activity, particularly its intense and frequent solar flares. These flares are sudden, powerful eruptions of energy that release high doses of X-rays and ultraviolet radiation. Such events are far more common and energetic in red dwarfs than in stars like our Sun. For Proxima B, this means a constant bombardment of high-energy particles, which could strip away the planet's atmosphere over time without a protective magnetic field. Any atmosphere on Proxima B would be vulnerable to erosion, leaving its surface exposed to harsh radiation. Even if Proxima B retains some of its atmosphere, radiation from Proxima Centauri poses serious challenges to life. High levels of ultraviolet radiation can break molecular bonds, preventing the formation of complex organic compounds. This would severely limit the potential for life to develop or sustain itself on the planet's surface. On Earth, organisms like Dionicus radio have evolved mechanisms to repair DNA damage caused by radiation, suggesting that life on Proxima B might similarly adapt. However, the level of radiation resistance required would be extreme, possibly necessitating entirely new biochemistries. Interestingly, Proxima B's tidally locked nature may offer some protection. While one hemisphere faces constant radiation from Proxima Centauri, the planet's dark side could serve as a refuge. Subsurface habitats or deep caves could shield potential life forms from the worst of the radiation. Similarly, if Proxima B has subsurface oceans, they could provide a stable radiation-free environment where microbial life might thrive, much like the ecosystems around hydrothermal vents on Earth. Despite these challenges, scientists remain hopeful that Proxima B's extreme environment provides a unique opportunity to study the adaptability of life by observing how organisms might survive or even thrive under such conditions. Researchers can expand their understanding of what makes a planet habitable. Proxima B is not just a potential home for life, it is a natural laboratory for testing the limits of life itself. The planet's proximity to Earth and its position within the habitable zone of its star make it an ideal candidate for further study. With new telescopes and missions on the horizon, Proxima B will remain a focal point in the search for life beyond Earth. If we are to find evidence of extraterrestrial life, Proxima B might very well be the first place we look at. Serves as a reminder that even in the harshest environments, life may find a way. As we continue to push the boundaries of space exploration, Proxima B will remain a key part of the puzzle, offering clues about the potential for life in our own cosmic backyard. With continued research and observation, the mysteries of Proxima B may one day be unraveled, shedding light on the existence of life beyond our planet. The quest for life beyond Earth is a journey that spans not just years but generations. As technology advances and our knowledge of the universe expands, the search for habitable planets will continue. Proxima B, with its many challenges and possibilities, stands as a symbol of humanity's drive to explore the unknown. Whether or not we find signs of life on Proxima B, the pursuit of this goal will undoubtedly lead to new discoveries and a deeper understanding of the cosmos. It is a search that may one day reveal answers to one of humanity's greatest questions: are we alone in the universe? As we continue to explore the cosmos, the discoveries we make about planets like Proxima B will serve as stepping stones for understanding the broader potential for life beyond our solar system. The search for habitable worlds, both near and far, has become one of the most exciting frontiers of modern science. Through telescopes like the James Webb Space Telescope and with advances in technology, we may one day answer the age-old question of whether life exists elsewhere in the universe. The discoveries that await us are not limited to just finding signs of life. Every new piece of data we gather helps us understand how planets evolve, how life might emerge, and what conditions are necessary for that life to flourish. It's a process that involves studying not only the planets themselves but also their stars, their atmospheres, and even the cosmic events that shape them. As we venture further into space, our understanding of the universe will continue to evolve, reshaping our view of what is possible. Proxima B, with all of its challenges, exemplifies the complexity and wonder of this search. The planet may seem inhospitable in many ways, but that is precisely what makes it such an important target for study. The more we learn about Proxima B, the more we learn about the potential limits of habitability and the resilience of life. If life can adapt to such extreme conditions, it would expand the possibilities of where we might find life elsewhere in the universe. The future of space exploration will likely bring us closer to answering these questions. The development of next-generation telescopes and space missions will allow us to peer deeper into distant star systems and analyze exoplanets with unprecedented detail. We may one day discover not only other Earth-like planets but also evidence of life on those planets, transforming our understanding of life in the universe. In the meantime, Proxima B stands as a testament to the curiosity and determination of scientists and explorers. It is a world that invites us to look beyond our own, to imagine what might be out there, and to continue striving for the answers to the most profound questions we can ask. Whether or not we find life on Proxima B, the pursuit of knowledge will continue to drive humanity forward, sparking new innovations and inspiring future generations to explore the stars. Thus, the journey of discovery continues, and the search for life beyond Earth is far from over. Every new mission, every new telescope, every new breakthrough brings us closer to understanding our place in the universe and the potential for life beyond our planet. Proxima B may be just one of many worlds that could one day be explored, but its role in shaping our scientific understanding is already profound. The quest for life, whether on Proxima B or on another distant planet, is a journey that unites us all in our shared curiosity about the cosmos. As we continue our search, the hope of finding other forms of life remains one of the greatest aspirations of our species.